Hi everyone, my name is Kalinth, and today I'll be walking you through a powerful tool in data forecasting, the Monte Carlo simulation. This method allows us to embrace uncertainty, not ignore it, which makes our prediction far more realistic and reliable. Let's explore how it works and why it matters. Now, let's start with the problem with traditional forecasting. Let's talk about a common situation. You want to predict your company revenue next month? You could simply take the average of past month and use that. But is that enough? What if sales drop due to external events or rise because of a promotion? Real world forecasting is full of variables we can't perfectly predict. Traditional forecasts give us just a single number, but that number can be misleading. What we need is a range and a sense of probability, which here is Monte Carlo simulation. Then what is Monte Carlo simulation? Named after the famous gambling city, this uses random sampling and probability distribution to simulate thousands of possible outcomes instead of just one. It was originally developed during the Manhattan Project in World War II, but today it's widely used in finance, project management, supply chains management, and risk management. Now let's talk about a classic example, estimating the value of pi. Imagine you don't know the formula for the area of a circle, but you can draw a circle inside a square. The square, the area of this square is easy. Is 2 times 2 equal 4. But the area of the circle is unknown, and we want to find it. Now, we would generate lots and lots of random points inside the square. These points are placed with equal probability, like throwing darts randomly on a dartboard. For each point, we will check if is inside the circle or if outside the circle. We color it blue. If not, we color it red. The fraction of points inside the circle tell us how much area the circle takes up. That's the key idea. Now let's see this in action with 10,000 random points. Here's what the output looked like when we run it in Python, and I will show you the code right now. Okay, so I'll write a Python program to estimate pi using Monte Carlo simulation. So as you can see here, I'm importing some NumPy for random number generation and also Matplotlib for later on plotting and visualization. And in this part, I will define how many random points I want to simulate. The more the better the estimate, but I'm using 10,000 here. And this is where we use the simulation. I'm generating random x and y values between -1 and 1. And these points will fall anywhere inside our square. And I will now check if each point falls inside the unit circle, and the condition will be square x plus square y smaller than and equal to 1. And I will calculate the proportion of points inside the circle and multiply it by 4 to estimate pi. I will also print the result out so we can all see what we have in here. Okay, we're getting approximately 3.14, which is a good result. All right, move on to the final part. You can see here I'm visualizing the result. So I will put red dots for outside the circle and blue dots for inside the circle. This simulation should give a solid estimate of pi within just a few lines of code. Okay, so you can see the output in this scatter plot. The blue points are those that landed inside the circle, and the red ones are outside. With 10,000 points, we get a pretty good approximation of pi. In this case, around 3.136. The more points we simulate, the more accurate our estimate will be. Now let's talk about advantages and limitation. Monte Carlo simulation is powerful because it helps us estimate values or outcome when direct calculation is difficult. It's great for uncertainty, risk modeling, and probabilistic forecasting. But it's not perfect. Your result depend heavily on input assumption, the quality of randomness, and the number of simulation. So, more simulation generally means better accuracy, but also more computation. To summarize, Monte Carlo simulation turns randomness into insight. It's intuitive, visual, and easy to implement in code. Whether whether we are estimating pi or forecasting sales, this technique gives us not just one answer, but a range of possibilities along with their probabilities. And that's everything for today. Thank you for watching. This project was built in Python, and the code and the voice are by me, and I hope this gave you a clear, fun introduction to Monte Carlo simulation. See you next time.